Wooden utility poles are a constant presence in our lives. They were originally built in the mid-19th century to suspend telegraph lines. Now they hold up power and phone lines, as well as fiber optic and coaxial cables for television and computer networking. Builders use many different types of pine or fir trees to make utility poles. In the U.S., southern yellow pine is the most popular choice. Foresters select trees that are 10 to 20 inches in diameter and at least 30 feet high. They look for a straight, healthy trunk with few limbs. The foresters mark the selected trees with spray paint. Then the tree harvester saws them down at the base. After the loggers saw off the limbs and cut the trees to a specified length, a log truck delivers the poles to the mill. There, a truck scale weighs the load. Then workers ticket it with a tracking number. The truck enters the yard and the poles are unloaded into piles. A loader feeds the poles to a debarking machine. The machine's razor-sharp cutters shave off the bark and the layer of tissue beneath the bark called the cambium. Next, a saw trims 1 inch off the bottom of the log to make it square. At the same time, nozzles spray lines of red food coloring at set intervals along the pole. These marks indicate different lengths. Another worker inspects the quality and measures the circumference. This assessment determines the wood's class. He marks the length and class on the bottom of the pole. The bark and shavings removed from the poles don't go to waste. A grinding mill reduces them to small fibers. The factory uses those fibers to power the boiler. The fire in the boiler will produce heat, which dries the poles. After the poles have been sorted by length and class, loaders stack them on large trams. They place spacer sticks in between each pole to allow air to flow around them. Then the loaders push the trams into a large kiln. The steam from the boiler flows through the trams, heating the inside of the kiln to 200 degrees Fahrenheit. Large fans blow the hot air around the poles for 3 days until the wood is dry. When the poles come out of the kiln, workers brand them with product information. Next, they cut a flat surface on one side of the pole. Then they drill holes to attach a cross arm. After they drill the holes, they stack the poles in another tram. This one takes them to a 125-foot-long treatment cylinder. They lock the door and vacuum all the air out of the cylinder. They fill the cylinder with a liquid that's 98% water and 2% chemical preservative. The preservative is a mixture of chrome, copper, and arsenic. Once the cylinder is full, the pumps start running to pressurize the liquid, infusing the wood with the chemical solution. The 2-hour process leaves the wood resistant to rot, fungus, and termites. Next, inspectors bore 3-inch holes into each pole to collect a sample. The inspectors check to make sure the preservative saturated the wood to the target depth. Then they send the samples to the on-site laboratory, where they're dried in a microwave oven and ground up. They also put the sample in an X-ray machine to analyze the chrome, copper, and arsenic levels. These quality control steps ensure that every utility pole contains the right amount of chemical preservatives. These finished bowls will last for at least 45 to 60 years.